Good morning, students. Welcome to last session of chapter 1, rational and irrational numbers. In the previous session, we saw what are irrational numbers and representation of root 2 on a number line. In this session, we will represent few more irrational numbers on a number line. Practice at 1.4, we have to complete the given activity to represent root 3 on the number line using root 2. The number root 2 is shown on a number line. Steps are given to show root 3 on the number line using root 2. Fill in the boxes properly and complete the activity. The point Q on the number line shows the number. So here is point Q and this point Q shows the number root 2. So here we will write root 2. A line perpendicular to the number line is drawn through the point Q. Point R is at unit distance from Q on the line. So this is a perpendicular through point Q. Now, and point R is at unit distance from Q on the line. This point R is at a unit distance from this point Q. Right angle triangle ORQ is obtained by drawing segment OR. In right angle triangle ORQ, length OQ is equal to root 2 and length QR is equal to 1. Therefore, by Pythagoras theorem, square of length OR is equal to square of length OQ plus square of length QR. Now, length OQ is equal to root 2. So here we will write root 2. And length of QR is 1. So we will write here 1. Now root 2 into root 2. Root 2 into root 2 is equal to 2. So here we will write 2 and 1 into 1 is 1. 2 plus 1, 3. Now square of length OR is equal to 3. Therefore, length of OR is equal to root 3 by finding square root of both the sides. Now, this length OR is root 3. So, we will take O as a center and OR as radius. We will draw an arc which will intersect our number line and we will name the point of intersection C. And this point C represent root 3. Students, do you know which numbers are called perfect squares? Now you might be thinking, why teacher is asking perfect squares in this chapter? Let's see. A natural number is said to be a perfect square if it is the square of another natural number. Now here, I have written first 9 natural numbers. Now let's see among these which numbers are perfect squares. Is 1 is a perfect square? Yes. 1 is the square of 1. 2 is a perfect square? No. 3 is a perfect square? No. 4 is a perfect square? Yes. 4 is the square of 2. Is 5 is a perfect square? No. 6 is a perfect square? No. 7 is a perfect square? No. 8 is a perfect square? No. Is 9 is a perfect square? Yes. 9 is a perfect square of 3. Now if I will find the square root of all the numbers. So the square root of 1, 1. What was the square root of 2? Root 2 only. Square root of 3? Root 3. Square root of 4? 2. Square root of 5? Root 5. Square root of 6? Root 6. Square root of 7? Root 7. Square root of 8? Root 8. Square root of 9? 3. So now students, the number Root 2, root 3 will lie between integers 1 and 2. Root 5, root 6, root 7, root 8 will lie between integers 2 and 3. In next problem, we have to represent root 5 on the number line. To represent root 5 on the number line, we will construct a right angle triangle such that whose one side will be of 2 units and other side will be of 1 unit. As according to Pythagoras theorem, we will get 2 square plus 1 square is equal to hypotenuse square. Square of 2 is 4 and square of 1 is 1. So we will get 4 plus 1, 5. So we will get hypotenuse square 5. So hypotenuse is equal to root 5. Let us show root 5 on the number line. Show the number root 5 on the number line. So here is our number line where O represent 0 and point A represent 2. Now through point A we will draw perpendicular to the number line. Mark point P on this perpendicular at a distance of 1 unit from point A. This is distance of 1 unit. We will mark the same distance on this perpendicular and we will name the point P. Now this length of OA is 2 units and length of AP is 1 unit. We will draw segment OP. Now right angle triangle OAP is formed. So we have seen in rough work, if we will construct a right angle triangle with side 2 units and 1 unit, the hypotenuse will be root 5 units. So therefore, this OP is root 5 units. Now we will take O as a center, OP as a radius. We will draw an arc which will intersect our number line. And we will name the point of intersection as B. And this point B represent root 5. Here is justification in right angle triangle OAP. Length of OA is equal to 2 units, length of AP is equal to 1 unit and measure of angle A is equal to 90 degree. 2 units, 1 unit and 90 degree. Therefore, by Pythagoras theorem, we will get square of length OP is equal to square of length OA plus square of length AP. So length of OA is equal to 2 units and length of AP is equal to 1 unit. So we will get square of 2, 4 and square of 1, 1. So square of length OP is equal to 4 plus 1, 5 units. To find length of OP, we will find square root of both the sides. So we will get length of OP is equal to length is square root of 5. Length of OP is equal to length of OB and therefore length of OB is equal to root 5 units. Therefore, B represents root 5. To represent root 6 on the number line, first we will represent root 5 on the number line and then with the help of root 5, we will represent root 6. To represent root 7 on the number line, first we will represent root 5. Then with the help of root 5, we will represent root 6. And then with the help of root 6, we will represent root 7. As we represented root 3 with the help of root 2. So students, in this chapter, we have learned to show rational numbers on a number line, comparison of rational numbers, decimal representation of rational numbers. We saw the decimal representation of rational number is either terminating or non-terminating recurring. We also saw the numbers on a number line which are not rational are called irrational numbers. We also located few irrational numbers on a number line. I hope all of you have understood these concepts. Practice all this. Take care. Bye. Thank you.